I bet. I cannot relate at all.
All right, we're finally ready to begin. So just kind of read that. Basically, digestion is the process of breaking food down. And I think a good place to start is actually this slide because it shows a general overview of the whole system. And we see that this digestive system is really a gastrointestinal tract. Begins at the mouth, cavity, and ends at the anus, and we'll talk about it, everything in between. So I just call it the GI tract for short. And the general pattern we'll talk about, but the processes that we'll talk about throughout are listed on the side there. Starting with ingestion. Digestion begins the process. That's simply stick it in your mouth. You begin the process of digestion. When, for example, when you chew your food, that's the process of mechanical digestion. Mechanical digestion, just like it sounds, you're just pummeling your food. It's a physical breakdown of the food. Now, when you break down your food in your mouth, you chew. And the word for chew in this class is mastication. You chew your food. You add some, so basically the mouth, the oral cavity, because you got your chompers in there. That's a good place for mechanical digestion. When you swallow your food, and the stomach does pretty much most of the rest of the mechanical digestion. The stomach churning and the stomach acid. We'll just physically break the food down into smaller and smaller products. Now, the next word there is propulsion. I'm not going to write that word. I'm going to write the word in parentheses. Peristalsis is accomplished by, it's the muscle layer within the GI tract wall, which we'll look at soon. And so there's a few muscle layers, but the one in particular is the Muscularis Externa. Be able to push food in one direction. It's an organized contraction of the smooth muscle. Moves food in one direction. So that's all I'll put. I mean, can see that it starts at the mouth and it pushes food all the way one way. If you want to take like a wet string or ribbon that's like 25 feet long and swallow it, and just keep swallowing it, you can eventually pull out the other end. It'll just keep going. Okay? It's one way to cleanse your inside. Peristalsis will get the string all the way to the other end, just like the food. It all moves all the way to the end, to the digestive tract. Now, along the way, you have chemical digestion. This pretty much follows mechanical digestion. This is where enzymes are actually breaking the food molecules down from polymers to monomers. So you're breaking chemical bonds at the molecular level. Enzymes, bile, throw that in there. Break food down at the molecular level. Now, the two places we see that, it actually starts in the mouth. You have an enzyme in the mouth, the oral cavity. Salivary amylase, which can actually break down the starches and the simple sugars. In the stomach, you have pepsinogen. The stomach acid will activate that into pepsin. Pepsin can actually digest proteins, and that begins in the stomach. Okay, I would say primarily the duodenum receives most of the chemicals for this digestion. The duodenum is the first part of the small intestine after the stomach, as we'll see. You're going to get secretions from the liver and pancreas. And those chemicals, I feel, accomplish most of this chemical digestion. Duodenum receives.
Did you say polymers to monomers?
Yeah, I did say that. It receives bile and pancreatic enzymes. And that's most of the chemical digestion. But it continues on because the small intestine is 21 feet, and if you still have more chemical digestion to accomplish for absorption, there are brush border enzymes along the mucosa of the full length of the small intestine that can accomplish it. So, small intestine, the duodenum small intestine. It's the first 10 inches, but you got 21 feet of small intestine. So I'm just saying, along the rest of the 21 feet, brush border enzymes. So once you've broken the food down at the chemical level, the molecules should be small enough to be absorbed into the bloodstream. So that's the next thing I have, absorption. Of course, the small intestine, that's what it's designed for. The The small intestine, well, it's not small because of its length. It's small because of its diameter compared to the large intestine, maybe 1 inch versus 3 inches in diameter in terms of the tube diameter. Now the small intestine, that's its main job. It's modified for absorption. And molecules that are, for example, fat globules, which may be too large to be absorbed into intestinal capillaries, will be absorbed into lymph. So most food stuff is absorbed, I'll say absorption, the intestinal capillaries, the regular blood capillaries. And fat globules that are too large to be absorbed through blood capillaries, the lacteals. Well, it's a lymph vessel, the green one, that can absorb through there. Okay, so absorption of fat, the lacteals. So lacteal is the structure for fat. And then what is not absorbed passes all the way through to the distal colon. When you get to the large intestine, or colon, that is, there's not much left to absorb. Maybe water and fat-soluble vitamins are all that's left to be absorbed. And then you compact the feces. Fat-soluble vitamins. When you compact the feces, you basically are ready for defecation at the rectum anus. The rectum, well, you can't tell from this picture, it follows the curvature of the sacrum. So you're basically in the pelvis by the time you get to the end there. Think of, anatomically, you're top of the sacrum, and this is kind of like a holding chamber for the feces. The feces will stretch or distend the rectal wall. And then there's a reflex. The muscle contracts when it's distended. That's the reflex. And that pushes the feces towards the anal canal. So it's a stretch reflex, which makes it contract. So then you push feces toward anal canal. That's when you should feel the urge to go. And well, you can decide, I'm going to make it to the bathroom, or if I hold it in, because you have an external anal sphincter that's controlled by conscious thought that can help you hold it in. There's an internal anal sphincter, but that's smooth muscle. But it's the external one, that skeletal muscle, you can control with conscious thought. Voluntary, I'll call it voluntary effort, to hold it in. So defecation is of materials that could not be absorbed, that passed right through you. fibers or roughage from the food you ate. I'll just describe it as defecation of food stuff not absorbed, passed right through you. Some people can call defecation excretion. It's not, because it was never absorbed. Excretion is something that was in you and you filtered it out and excreted it. All right, so that's just kind of an overview. To get into the details of this, it's good to study this figure. If you were to study the digestive tract anywhere, it should have the same general pattern. And that's kind of what you learn from this figure. Now, when I teach the histology of the digestive tract, what I think you'll notice is there's 4 spots that we're going to study. And no matter where we are in the GI tract, you need to know the organ that we're studying based on this general pattern. Follows the same general pattern. You got mucosa, submucosa, muscularis externa, serosa. Now I put them in red. One of them's covered up there. So I'll go through them one at a time, but it's the same general pattern. What I want to write is, can you tell if you're in the esophagus, small intestine, no, I skipped one. Esophagus, stomach, small intestine, colon. Those are the 4 spots we'll look in the histology slides, and you should be able to tell which one it is based on the GI tract wall. So we'll study for esophagus, stomach, small intestine, large intestine, so that's supposed to say mucosa, so write it down here. And I pulled it up because I want you to see all the different parts of it so I can color it in. Now, the mucosa, like we've been talking about mucosa a lot, is just basically the inner lining of a tube. And the mucosa, at the center of it, the lumen is the space that food is passing along. So all right, surrounds lumen. That's food passing right along top. And the innermost lining of the mucosa, like anything else, is the epithelium. Now the epithelium, right here, I'm just going to trace it here. You should be able to identify the epithelium. It will change depending on the function. Then most of what you'll see in terms of the epithelium, it'll either be stratified, squamous, or columnar. That's primarily what we'll see. So it changes depending on function. generally speaking, I'll say stratified squamous, that function is protective. You kind of can slough off the top layers and the bottom layers will replace it. Like for example, mouth esophagus, at the beginning when you swallow food, and there may be sharp edges of like bread crust or potato chips that you swallowed. You want to protect the mucosa from. So, oral cavity, esophagus. You get down the stomach, it changes from pretty much stomach all the way down. Going to be a simple columnar. Epithelium and well, the mucosa is arranged in different ways, but pretty much stomach all the way up to anus. And anus, it'll reverse. It'll stop there, and then the anus is something else. It goes back to a stratified squamous. So basically, it changes based upon function. Now the epithelium, they draw like a bunch of like glands going into it. That's why they have all of these ducts leading into the lumen. And well, I guess one thing I could identify is any gland or organ that secretes into the digestive tract but is not a part of the tract itself is called an accessory organ of digestion. Put that as a note. Accessory organs. I'll write it up here. Accessory organs of digestion. Not in the tract, but to secrete into it. We'll talk about those. But okay, to get back to the general structure, okay, surrounding the epithelium, basically you have this connective tissue called the lamina propria. Now the lamina propria may contain other things like glands, but we usually just see it as a loose connective tissue. I drew it in blue. Loose CT. Now one structure they have in there that we'll look at is the malt, the mucosa associated lymphoid tissue. That's there. These green things here. We got another one there. Okay, that's malt. And I've wrote it out before, I'm not going to write it out again. I always just like to call it malt. It's green on there. Mucosa associated lymphoid tissue. Surrounding the lamina propria is a muscle layer. Students always miss this one. So I'm going to do a careful job to trace it well. It's a part of the mucosa. And you can see all the muscle fibers running in this orientation. The Muscularis mucosa. So this is the only time that where you see a muscle layer in a mucosa. Mucosa has its own muscle layer, and that's good because it increases the agitation of food by having a muscle layer here. Increase agitation of food. Okay, all of those things, the epithelium, the lamina propria, and the muscularis mucosa are part of the mucosa. You'll have to be able to identify them. Now, surrounding that is the smooth, is a loose CT called the submucosa. And on this figure, it's all of this connective tissue area here. I try to color it all in, but basically, there's a lot of stuff in the submucosa. So I'm going to clear this, and I'm going to write submucosa. I need a button to push, so I can just erase the board automatically. I wish I had a dollar every time I erase the board. The submucosa well, just its name tells you it's underneath the mucosa. It's kind of surrounding it. Well, there's some nerves in there. Whenever you see yellow lines in textbooks, it always means nerves. And there's something called the submucosal plexus that I want you to be able to identify. And there's also glands in there called Brunner's glands, spelled Brunner's. Brunner's glands, we're going to see those only in duodenum. And that's important. They secrete an alkaline secretion that will neutralize stomach acid, because that is what, well, the duodenum's after the stomach. So that's important. Secrete alkaline fluid. Neutralize stomach acid. So all of these glands that they draw here in the submucosa, I'll call them orange. They symbolize glands in this area, this region. And we're going to study them as Brunner's glands. Only in the duodenum I will point them out when we look at histology. So those two structures, the plexus, the Brunner's glands, that's it. Okay, be able to identify the submucosa as a layer and find those things in it, and that's pretty much it. Now we have models that show the nerves. I never see them in histology slides. Of course, I never really look for them, but we will see the Brunner's glands on histology slides. Now, the GI tract has a very significant muscle layer, and it's bilayered. It's called the Muscularis Externa, as I alluded to before. The Muscularis Externa, not to be confused with Muscularis mucosa, is usually bilayered. And you have to tell layer from layer. Well, the inner layer is a circular layer, and the outer layer, the direction of the smooth muscle cells are longitudinal. So you have this inner circular layer, and you have an outer longitudinal layer. So I'll try to point that out to you. It's this layer right there. I think they do a good job illustrating this one. I'm going to trace just around the circular layer. Okay, so I've traced just around the circular layer. And what I want you to see, you look in your book. If you look right where they cut here, like the smooth muscle cells, they go in a circular orientation. In the circular layer, maybe it's easier for me to draw here. The smooth muscle cells are arranged in a circle. That way, when they contract, they squeeze. Okay, so they're able to pinch the tube, and that'll help propel the food forward. So if I have a tube and I'm arranged in a circle, I can squeeze in one location. This is what the circular layer can accomplish by squeezing. And because you have another layer where the cells run longitudinally, I'll finish tracing this here. The first layer, this is circular. The outer layer they're all longitudinal. They're running the length of the tube, and that's all I'll highlight there. So the longitudinal layer, what they can do is they can kind of like squish the tube. So by squeezing and then by kind of scrunching, you're able to push the food in one direction. Now, I don't know if this is helping you, but what I want you to know about the organized contraction of these two layers is it accomplishes peristalsis. And it's the bilayered nature of the muscle fibers being oriented at 90 degrees that allow the cell to do this. Or, excuse me, allow the GI tract to do this. When you get to the stomach, I want you to look for a third layer. Only in the stomach you have 3 layers. Everywhere else, look for the 2 layers. In the stomach only, look for an oblique layer. All right, so let's move on. Adventitia. We call it the Serosa or Adventitia. They wrap around the digestive tract, but they pinch on one side, forming the mesentery. Now the mesentery, they attach to the back body wall. So instead of trying to trace the whole thing, I'm going to draw this. Here's the digestive tract in cross section. The serosa would simply surround it. and be the outermost layer. And then where it kind of meets in the back, kind of shoots back to the back body wall. So my black line represents back body wall. So what do I mean by that? Take off my entire front, dig out all the organs, and look at the back from the inside. Back body wall from the inside. Black line. It's lined with this blue line, which is a serosa. It's basically we call it the parietal peritoneum. So we call this, that actually lines the visceral organ, the visceral peritoneum. It's one and the same as the serosa. And where it pinches in a double fold right there, that's called mesentery. So look at the figure. Do you see the mesentery? It's important. I'll point it out to you. It's bottom left right there. But you see how the mesentery contains nerve, artery, vein, and lymphatics. So that's kind of how you get stuff to every inch of the digestive tract. And we'll study the mesenteries, but that's basically the arrangement. Okay. Mucosa, submucosa, Muscularis Externa, adventitia, serosa, which form mesentery. Okay, let me pull this back out. Oh, one thing I forgot. The mesenteric plexus are nerves between the layers of the Muscularis Externa. So let's add that to your notes. You have submucosal plexus, mesenteric plexus, nerves. So of all the things labeled, just note those plexuses. They form the ENS. It's kind of another lesser told, celebrated nervous system. We always teach the somatic and autonomic, but we don't give much mention to the enteric nervous system. So let me at least write it on the board so you have it in your notes. I'm just going to call it the ENS. And both of these plexuses are the main nerve plexuses of the ENS. I've seen it called mini brain. All you have to do is chew and swallow. That's all you have to do. The rest is done by mini brain. Okay? Takes over and everything happens on autopilot. Here's a model we have in the room, and I've kind of eliminated some of the numbers, but you should be able to identify everything that I have labeled on here. We're going to start off with, we have our 4 layers, and this happens to be the small intestine. So the mucosa, the bottom structure of the mucosa is number 9. And that's the thing I said students miss most. Muscularis mucosa. And, well, I always say that because I hope students don't miss it this time. But notice the mucosa, these finger-like projections, and then there's these pits. So basically, if I could simplify that on the board. For the small intestine, it's like you have this upward projection and then a pit. villi, pit, villi, pit. That's kind of what you're seeing there. So the thing that sticks up, villus, which means finger-like projection, but it's all mucosa. And this is called the intestinal crypt. On your study guide, it may say crypts of Lieberkuhn. With Paneth cells. So there are Paneth cells in both. I mean, Paneth cells is a different cell structure. Paneth cells are eosinophilic, they're red. They're always modeled and they're always shown in the histology slides. So if you look at the crypt that's right here, number 15, and at the bottom of it you see the red cells, those are the Paneth cells, and you'll be asked to identify those. If you have this model and you want to look at it in the classroom, if you look on the side, you'll see them too. If you look at number 4, it's trying to point to the gray tissue, Lamina Propria. Okay. If you look inside of villi, there's a couple of things. Well, number 3 is pointing to intestinal capillaries. And you see intestinal capillaries right there. The green thing, number 2, is lacteal. You're supposed to be able to identify that as well. You are responsible for that. So if we go to the next layer, deep to the Muscularis mucosa, you know, from here to here is basically submucosa. And if I point to like number 7, any yellow line, submucosal plexus. 11 is mold. 10, Brunner's glands. So you get to the next layer, 12A, 12B. It's bilayered. An inner circular layer, outer longitudinal layer. Which organ has 3 layers? We just wrote that down. Stomach. We'll get to that. And then you have the serosa adventitia. The serosa is simple squamous epithelium. There's some connective tissue there, but well, let's move on. That's a good model to study. We have other models in the room. I took a picture of this. This is in the classroom. It's back there somewhere. Look for it. Look for it if you want to study it in the classroom. And I have it labeled there, all the layers. And this is a good color of what the serosa really looks like on a cadaver. I will present most of these structures on our cadavers. Here's a colon that we have in the room. And they kind of like section out all the layers right there. So this one's not labeled. So it goes mucosa, and what's next? Submucosa, and what's next? Well, Muscularis Externa is the circular layer. The longitudinal layer is running this way. But do you see how the longitudinal layer is not a complete layer? It's a thin band in the large intestine. Anyways, serosa. So once again, mucosa, submucosa, the circular layer, longitudinal layer of the Muscularis Externa and the serosa at the end. All right, so those are some of the layers of the GI tract wall. I did want to talk about the mesentery a little more. It's a double membrane. It's a double wall of peritoneum here. And you have figures in your book that do kind of show you what's meant by mesentery, and also the terms intra versus retroperitoneal. People say intraperitoneal, it's in the body cavity. You remove the ab wall, and you look in the body cavity, you can see it. It's in there. Retroperitoneal, like this illustration implies, you're behind the body wall. Okay, like if you were putting up wallpaper, and I stand against the wall, and you put wallpaper over me, I would be retroperitoneal, okay? You could probably see a big bulge. Hey, what's that big bulge? It's Dr. Wani's behind the wallpaper. That's like this. You can see organs that are retroperitoneal. They're just kind of over this, they're kind of under this serosa membrane. Okay. I'll just say they're behind the parietal peritoneum. So obviously organs that are retroperitoneal, they're harder to see. You just have to kind of like sweep everything aside so you kind of know what you're looking for, and eventually you'll find them. Well, here's a sagittal view. I think this is a good view to study for all of the mesenteries you have to know. It might help to draw it out. So in the front, I'm just going to do a crude drawing here. I mean, the boundary between the chest cavity and the ab cavity is diaphragm. So and they show the liver on the top there. And below that they have, I believe, stomach. And below that you have transverse colon. And then they show a bunch of cut small intestine, which are mostly the jejunum and the ileum, small intestine. I won't draw that many, but I'll draw some. I'll just call it small intestine. And they draw a couple of things that are retroperitoneal. Pancreas and the duodenum. So let me start by drawing right here, I guess. This represents the back body wall. So my blue line is going to represent, well, when it's on the back body wall, we're going to call it the parietal peritoneal. And it's going to go up and it's going to line the inside or the underneath of the diaphragm. There's a part where the peritoneum is going to shoot down on top of the liver. So right, barely sits right there. It shoots down on top of the liver. And when you're on an organ, you change from parietal to visceral, but I'm not going to change colors. I'm going to keep it all blue. So this part continues on, shoots down. So you see there's a very small part of the liver that's not covered. It's bare. And they call it the bare area of the liver. Finally, a term that makes sense. Bare area of liver. The part that's not covered with the peritoneum. Well, anyways, I'm going to continue my blue line all the way around the liver. It's covered. And there's a part that's going to shoot down and then go over stomach. And before I continue any further, that is called the lesser omentum. This right here. You are responsible to identify lesser omentum between liver and stomach. Let's continue on. With the visceral peritoneum around stomach, there's going to be this big fat apron that comes off the stomach and then drapes down in front of the intestine and back up and goes to transverse colon. So it's called the greater omentum. It goes from, again, stomach, loops down like a fat apron, boom. I'm going to draw to draw going to this, I'm sorry. I knew I should have practiced drawing this. Jeez. I'll get it, don't worry about it. And you go to transverse colon, that's better. Okay, here we go. So you go from boom all the way down to there, all the way up to, there we go. Okay, so now my apron has gone all the way down and moved back up to the transverse colon. And this whole thing is going to be called, all that is called the greater omentum. Now in terms of the transverse colon, the mesentery, it's going to shoot back to the body wall right here. Boom, boom. And it's called the transverse mesocolon. Okay, so this part right there, it goes back to the body wall and anchors it. Transverse mesocolon. There's going to be a mesentery that shoots out, and then it's going to cover all of the small intestines. That completes it. The last mesentery I'll mention is the one that anchors all the small intestine to the back body wall. It's referred to as the root of the mesentery. This one here. Root of the mesentery. The one for all the rest of the small intestines there. Those are all the ones I'll have you know. Notice how pancreas and duodenum, well, based on the drawing in the picture, are pancreas and duodenum intra or retro? Retro. They're behind the peritoneum. Okay. Well, I included some other pictures to help you learn the mesenteries from the atlas. And, well, I called it the big fat apron. Now you can see why. The greater omentum, well, why is it called greater omentum and lesser omentum? The stomach has a greater curvature and a blank curvature, fill in the blank, lesser curvature. So that membrane is lesser omentum. The big fat apron is the greater omentum. That's transverse mesocolon. So what you did was, if you lift up the fat apron and lift on the bottom side of the transverse colon, you can see the transverse mesocolon. So I'll do that on the cadaver. I'll just kind of like lift it up, and then you can see the transverse colon underneath, and you can see how it goes from stomach to transverse colon. Okay. For now, just memorize it, and then I'll show you and try to remind you of that. Well, there it is there. Okay, so I know what I'm looking at. Here's my fat apron, greater omentum, transverse mesocolon, small intestine, transverse colon, the gray, transverse mesocolon going to the back body wall. Now you may not know what that is. It's the first part of the small intestine, which is, starts with a D, duodenum. You got the pancreas and the pancreatic duct there, so we'll get to all that stuff. Just pointing out transverse mesocolon for now. So if you kind of go through the entire digestive tract, I like to start with the oral cavity and just obviously indirect rectum anus, and talk about the accessory organs along the way. And this is something we can all relate to. I think this picture is more for the dental hygiene students, but we can learn from it. You can see the uvula hanging in the back. Do you remember writing the word fauces in your notes? And palatine tonsil? You can see them there. Your adenoids, those are the ones that may get removed if they're remarkably infected. Well, I'll stick to things that help us chew and digest our food for this lecture. We could spend an hour talking about the oral cavity. I've seen people do it, I'll never do it, but I just want to mention like teeth and salivary glands, things that help you digest the food. Of course, you have tongue for taste buds, but taste is usually taught in 430. Well, you have a space between lipping gums or cheeking gums, and that's called the vestibule, the oral vestibule. So we'll start with the oral cavity. Space between lips and gums. Well, the word for gums in anatomy is gingiva. The E pluralizes it. So either lips and gums or cheeks. Cheeks and gums. And what's kind of like if you wear a U-shaped mouthpiece, it kind of fits in the vestibule. Okay. Now, the oral cavity, I don't like where they put the leader line. The oral cavity is pretty much the space between tongue and palate. You can see your teeth lining your jaw. And you secrete saliva into this oral cavity, and you are responsible for these salivary glands, the names, their nervous innervation, and even their histology. So the one listed on the left there is the parotid. I mentioned it before because it's where the external parotid terminates, but now we need to know it for itself. You have the parotid, salivary gland, and the innervation is listed there. 9. That's the glossopharyngeal. So this function, salivation, is parasympathetic. It's visceral motor. Let's call it that. It's visceral motor. On the right, IX for my 9 to remind us of the innervation. The duct is very long. It's right there. It is labeled. You see a little smidge of it right there. The parotid duct will kind of pierce the buccinator muscle, and it's going to secrete by the second molar of your upper jaw. So be able to identify this, the parotid salivary gland and the parotid duct. Now they all have ducts, but the parotid duct is usually the one I like to tag because it's very long and noticeable. This duct is the longest. Okay, let's list the other ones here. You have submandibular salivary gland. And then sublingual salivary gland. And they're both innervated by 7 there. Some books list 5, but I go with 7 because it has to do with how the nerve fibers piggyback on each other. You follow the black lines. Start right there with 7. And you go there, and you go there. I mean, some of them kind of like come from 5, but I just kind of stick with 7 for that. Anyways, the names tell you where you can find them. Mandible and under your tongue. Now their ducts, you can't really see on this picture. I'll tell you that the submandibular salivary gland, their duct length is like kind of more medium, and then the sublingual, right under your tongue, they have the shortest duct length. Now, saliva is a combination of a lubricating and digestive function. And the glands will have either mostly serous or mostly mucus or both. And when you stain slides that have a serous function, the watery fluid contains a protein, like a salivary amylase. And usually cells that are making proteins will stain very dark. And you can see that on a histology slide. But cells that secrete mucus, if it's a salivary gland that secretes mucus, mucus stains light. So you can kind of tell which of the 3 glands you're looking at based on the stain light, stain dark clue. Of course, the mucus cells are secreting mucus that moistens food for the lubrication. And I said earlier that amylase is a chemical digestion function. So the whole duct length thing is important because it turns out a watery secretion can travel down a duct, but a mucus secretion cannot. It would get stuck. So it helps to have a shorter duct length. A medium duct length would imply you kind of have both. And so if you look at the, I have an illustration of the histology I would like you to know. What I wanted you to see was that this is basically serous, totally serous. Because it has the longest duct length, and it's staining mostly dark. Then you go to the other end of the spectrum, it's mostly mucus. Stained light. That's why it has the shortest duct length. And then the middle, you can see it stains like light and dark pretty much. So it's basically serous and mucus. Stained dark and light. So kind of study the different salivary glands. So salivation is important for digestion, but also chewing is too. So I'll just give you two muscles of mastication to know, the temporalis and maxilla. Temporalis, maxilla. Their innervation is shown, I got a slide here. It's cranial nerve 3. That's what I wanted to get out of this picture. Innervation. V3, you should know that that's the mandibular division. That's what's on the slide. Okay. V3. The V refers to cranial nerve 5, if you recall. The third division. So those muscles help you chew. Chewing does no good unless you talk about the chompers themselves, the teeth. So we'll talk about the teeth. They're arranged. Well, you got upper teeth, lower teeth. You have upper jaw, lower jaw. You have maxillary teeth, mandibular teeth. Right? Maxillary teeth, just call it, think of it as upper jaw, but that's, the innervation is listed there. The maxillary division, you know, V2. I already said V3, but that's the innervation for teeth on the lower jaw. We call it mandibular teeth innervated by V3, because you can feel a toothache, right? So there's a lot of sensation there. And pretty much the branch of V3 you should know is the inferior alveolar nerve. Here's V3 at the root. But if you follow it down, it's giving off all these branches, including the motor division to the muscles of mastication. Then it's going to run through this mandibular canal. That's the mandibular foramen, by the way. But the mandibular canal is pretty much, at this point, you call it the branch of V3, inferior alveolar nerve in mandibular canal. If I ever had to have dental work done, I would much prefer the lower jaw, because you could do the nerve block in one shot. That's it. Just block that, and that whole quadrant is numb. That whole side of my mouth. Notice how the upper jaw, V2, there's no like one branch you could block. You would have to like block, if you had to say do these front teeth, you would have to like do several shots just to make sure you got all the cutaneous sensation numbed up. So just down here, just one shot on that side or the other side to block out the whole quadrant. Let's see here. Let's go back to slide here. Oh, this one. You know, there are different kinds of teeth. So let me erase this. Based on their cutting surfaces, their function is different. Some are for tearing, some are for chewing. You don't chew with your incisors, that's for tearing. So those are the two front teeth. Think of it as 32 teeth, 4 sets of 8. So in a set of 8, you got 2 incisors, and they're sharp for cutting. You have 1 fang or canine, a cone-shaped tooth. In us, it's more like a cone, less like a fang. 2 premolars. Molars are for chewing. These are also called your bicuspids. Now, a cusp is basically a cutting surface. Bicuspids and tricuspids are used for chewing. Premolars or tricuspids. So those are, well, that's 1 set of 8. You got 4 sets of 8, right? Based on the picture there. For 32 adult teeth. So that's the adult mouth. Oh, sorry, skip this slide. All right, this is just showing you the 4 sides of the tooth and the technical terms that are used. So they kind of like have this shape going on. So this side, mesial, that's the side of the tooth that's kind of closer to the midline. Midline, divide them out right there. Okay, so that's the side, mesial, distal, pretty much side opposite. So I'll just say distal is the side opposite. But the other 2 sides, the side facing the inside of your mouth, well, it would be the palate if it's the upper jaw. Palatal. This side, depending on if it's cheek or gums, would be the labial or buccal side. Buccal means cheek, labial means lips, depending on which tooth you're talking about. The occlusal, that's the top cutting surface or chewing surface. Make sure your bite is correct when you get dental work done. They always have your bite down on something to make sure your bite's okay, so you can chew properly. I did want to include a slide that kind of gives students a rough idea of when teeth fall out and erupt. Eruption of baby teeth, called deciduous teeth, like deciduous leaves, and they fall off. They erupt. These are years, okay, but then they fall out, like say starting in about 1st grade with the front teeth. And then the molars will come out at around 6th grade. And then the eruption of the adult teeth, again, starts in, about 2nd, 3rd grade maybe. It just continues throughout life, front teeth and the back teeth and the molars. The last molars are also called your wisdom teeth. They emerge last. And they're commonly removed because if the mouth isn't big enough to accommodate a 3rd molar, they may impact the tooth in front of it. That may cause a lot of pain. So they're commonly removed before that happens. You can see them in the x-ray about to arrive. The most, well, I've had mine removed. Here's how you code the teeth, 1 to 32. If you have an extraction, you don't renumber, you just skip it. So I've had all 4 of my wisdom teeth removed when I was 14. So I'm missing 1 to 32 and 16 and 17. So you just kind of skip those when you count my teeth and you don't renumber. Here's a structure of a tooth, a cross-sectional view. Looks like a canine tooth. You have crown, neck, root. Oops. No. Well, the crown of the tooth, the part you can see in your mouth, it's the part that's erupted above the gum line. Then the neck of the tooth is kind of like, well, it's where you floss. It's where tooth meets gum line. Because food can get stuck in there. Sometimes you feel the food, sometimes you don't, but you should floss anyways. And then, well, the root. The root of the tooth is where the tooth is anchored in alveolar bone. There are these periodontal ligaments that keep them bolted in. Tooth bolted in alveolar bone of the jaw, alveolar bone. Remember studying the alveolar process as a structural feature of the bone of the jaws. Okay, alveolar bone. The name of the joint is called a gonthosis joint. Let's see. Means bolted condition. We have those, like I said, periodontal ligaments. Kind of keep the tooth bolted into the tooth socket, basically. Well, you have the different parts of the tooth. The hardest tissue in the body is the enamel of your teeth. They're the most durable. 96% mineralized. That's a much higher percentage of mineralization than even bone. Now you want to protect your enamel. It doesn't grow back. If you grind your teeth at night, you grind your enamel away, you can't get it back, so they should get a mouth guard to wear at night, night guard. And so most of the tooth, as you can see from the picture, is dentin. Dentin is closer, it's less mineralized than enamel, something like 70% mineralized. Now it's hard to see, but the enamel ends there, and then there's a lining called cementum that lines more of the root of the tooth, and that is closer, a closer mineralized percentage to bone, about 50%, close to bone. Mineralized. Now inside the denum is soft tissue called the pulp chamber. And that's where the nerve and the blood supply is. Soft tissue. You got nerve. That's why you can feel the toothache. And blood vessels. You can see that the pulp chamber is continuous with the root canal on the bottom there. So cavities, or dental caries, so called here, is an erosion of all of these mineralized tissues. Sugary foods, hot sauces, like flaming hot Cheetos, those are particularly bad for teeth. Can erode. Now, if it erodes and you catch it and you fill it up, great. But if it erodes all the way to the pulp chamber where the nerve is, that's going to cause a massive toothache. Okay. If it gets infected, you can decide with your dentist if you want to save the tooth or extract it. If you save the tooth, you want to do, the root canal, which is usually a two-part procedure where the dentist will say to someone who's specialized in doing that, they'll make drill a bunch of holes. They'll basically suck out the pulp chamber, but they'll leave the blood supply. But they'll get rid of the nerve. That'll solve the problem of your toothache. And then you'll go back for a second appointment. They usually cap it. I think there are some more advanced procedures where they can kind of do it in one appointment, but usually it's a two-step procedure. Excavate, and then cap. Okay. All right, well anyways, chew your food. Now, the result of all of this, chewing your food, get saliva, mix it up, solubilize it so you can swallow it. The whole goal of chewing is to create a bolus of food. That's what you call a mouthful of food that you swallow. This is actually a good spot for a break. We'll pick it up here. Back at about 9:45.